Next speaker is Dr. Kenneth Kwok, the Principal Research Scientist from Institute of High Performance Computing. His presentation will be on AI-based situational awareness assessment. Let's put our hands together to welcome Kenneth.
So good afternoon, good morning, everyone. First time I'm speaking right on the stroke of 12 o'clock, so it's just before 12, so it's good morning still. So I'm Kenneth Kwok from the Institute of High Performance Computing, and I'm very pleased this morning to be able to share with you some work that we did in collaboration with the Singapore Polytechnic on AI-based situation awareness assessment. And this was actually generously funded by the Center of Excellence for Maritime Safety. So, maritime incidents at sea can often be traced to human error. And this is the big problem because humans are basically fallible, and the only way to sort of like prevent these things is to give them proper training, right? And we think that there is a lot that can be done using technology to enhance training. So our goal here is actually to address the training issue of soft competencies. So these are not the technical skills. These are basically soft competencies that have to do with teamwork, decision-making, communications. And in our case, we focus on something called situational awareness, which I'll explain a bit later more as we go into the talk. Right, and so this research was done in the simulators at the Singapore Maritime Institute, where students are trained on coastal navigation. And the targeted outcome from this work is to develop a system that is able to make assessments more objective and quicker using the technology that we introduced here. Right? And potentially this also allows for expertise to be retained and transferred into the system. So this is what the project looks like. We call it IBCAT, short for AI-based Behavioral Competency Assessment Tool. The goal of the system is to automatically generate assessments of students' behavior competencies with quantitative measures so that we can do objective assessments of soft skill competencies. So the problem currently is that human assessors are doing these kinds of evaluations. And these evaluations can be subjective because, human fallacy involved again. So to remove the subjective element to the best as possible, we try to introduce objective measures, right, that can be quantified. Our system comprises two parts, a behavioral learning understanding module and a competency assessment module, and I'll explain these as I go along. So what is situational awareness? It's jargon, but really what it means is whether the crew has a conscious awareness of events in the environment and what the implications of these events are. So it's very important if you are on a ship, or even if you're driving a car, imagine, right? You need to be aware of what's going on around you. And whether you are safe or not depends to a large extent on your awareness, your situational awareness, right? And in field research, the traditional way for assessing these things is actually to conduct an interview, right? So it's actually very difficult to do that. You actually interrupt the process if you do interviews. So we try to do this through observation instead of interviews. And we do this by looking at what we call key behavioral indicators, right? And working with the domain experts, people who are the instructors in this area, we identify relevant behaviors such as using radar, controlling the heading where you change course, or changing speed. All these are relevant behaviors that occur in reaction to what they are aware of in the situation, right? And so on. So we identified 7 initial key behavioral indicators. And so this is what our system pipeline looks like. I apologize ahead that I won't be able to go into very deep detail about AI especially because of the time constraint. But just to give you a broad idea of what we're doing and how it works, we first have to recognize the behavioral indicators I mentioned earlier using computer vision. Then we use something called behavioral learning. This is technology that we developed in IHPC. And we learn to characterize the behaviors of these students as behavior scripts. And then using these learned behaviors, we will then observe new data, observe the student when they're doing their navigation, and infer their competency and generate a report based on that. So this is what we're doing essentially. So diving a bit deeper into that, for the computer vision bit, we had to develop using deep learning models. So this is like the state-of-the-art approach for computer vision for recognizing events. We use 5-second long clips to train the model to recognize actually 5 different key events. We were unable to train the model on 2 events that were identified earlier, cause change and external comms, because of lack of data. These were relatively low frequency. The external comms was low frequency. But cause change is something that the student verbalizes. There's no obvious action from the student that you can detect using computer vision. So we were not able to do that using computer vision in this case. So the remaining 5 classes of action, key indicators, we were able to attain a 92% accuracy in recognizing these. So they look like this, right? So this shows that the system recognized the person was using the radar, and then he's then doing visual observation after that, right? And then here a person is plotting on a chart. So computer vision basically helps us to automatically detect these things instead of having a human observe these, right? So with the detections of the recognized behavior indicators, we go into the next stage, which is behavior learning. This is based on basically something we call unsupervised causal learning. And it's different from the current sort of hot deep learning based approaches, which are statistical and what we call sub-symbolic learning. Jargon again, I apologize. Let me explain a little bit. So in symbolic AI, we basically work off events, which are basically the symbols, right? We represent them as symbols. So here, I'm sorry, this thing doesn't come, you can't see the pointer. Okay, I'll walk over. So recall the key behavior indicators that I mentioned earlier. These were detected using computer vision. And then these are represented basically as symbols. You can see the numbers there. And so a behavior script is basically a sequence of behaviors that are meaningfully related across time, right? So the meaningfulness of this derives from the causal relation. And that's where our technology comes in. We use an algorithm that we developed that uncovers these temporal relations across events. And so you learn a behavior script from the data. And the beauty of this approach is that compared to statistical methods, we require a lot less data to train our models. So we only use 19 training videos in order to learn behavior scripts, right, like that. Okay. So that's a very long script. To make it more understandable, we broke it up into what we call complex events, right? So bear with me, it's a bit complicated here. Complex events are still sequences of events, except that they are actually recognizable by the experts, right? So we define these as events that start with an observation event, like using the radar or visual observation or plotting a position. These are like assessing their, observing their environment. And then they are then followed by a number of different events in between, and then they terminate with an action event. So an action event is something that has to do with cause change or speed change, or going into communications with internal or external parties, right? So it's quite intuitive. Basically, these are meaningful because they relate observations to then the consequences, the events, the actions that they take from these observations. Okay, so these are complex events, and so we can break up the script into shorter complex events. And an expert looking at that can meaningfully say, okay, doing an observation and then a cause change is something like a visual cause change. They put a description there. And these descriptive labels are then used in our report generation. So it's easy to understand when you look at the report instead of a series of numbers. The next step is to actually then, using, again, expert knowledge, this is the assessment rubrics that the assessors actually use when they do their assessments of students for situational awareness. So we then group these complex events into different classes, right? And based on these classes, we then do learn a regression rule to say, okay, based on the counts, I'll show you the counts later. But based on the observed events and the counts of these different complex events, the assessors also gave us an assessment of the students' performance, whether they were below expectation, meet expectation, or exceed expectation. And so based on that, we were able to do a regression and learn a rule. So long story short, what we did was that these are the counts in the table here. These are the different complex events that were detected by the system for this student. So there were 5 classes of these. And then using the regression rule, we can predict a score, right? And we compared this with the ranking of the instructor. So the score is between 1 and 3, because 1 is below expectation, 3 is expectation. So here, all the students are doing relatively well. They pass, so to speak. But there is a relative performance score here, right? So we actually can rank them, and the instructor's ranking sort of validated the system's ranking in this case. It's not always the case. Generally, the trend is there. But we actually need more data to validate this. This is still early work. And in terms of the report that I mentioned earlier, it comprises text, sort of human-readable text based on a temporal history of the lesson, as well as the quantifiable counts that we showed here on the chart. So here, the instructor then has got clear sort of quantified measures that they can use to justify their assessments, as well as they have the history and can zoom into events that are interesting when they're doing debriefing to the students using the video recordings in the simulator, right? So this is essentially what we did. So to conclude, the current assessments of competencies in navigation simulators are prone to human bias, as I mentioned. So the use of AI-based assessment tools to assess competencies can serve to remove some of this bias and provide some detailed specific analysis to aid instructors in making their assessments. Thank you. Welcome your questions.
Thank you, Kenneth. We have 3 questions for you. Let me pull out the first one. It's more on technical. It's more a technical question. How long is the computational time to generate the assessment report?
Yeah, so this is still sort of like a prototype system. We haven't have an actual production system built yet. That will be phase 2. Currently, it takes about 40 minutes to generate the reports because it has to run through the, generate the events, and then once the events are generated, it's fairly quick to actually then generate the report and the assessment. So it's really a limitation of the hardware at the moment. This can be optimized, and we hope to bring it down to 15 minutes, I think, with optimization.
Okay. There's another question on the regression model. What is the regression model used? And with 19 videos, will there be any overfitting problems?
Yeah, that's a good question. We basically use a simple linear regression. So it's nothing magical about that. But because of the magic really happens before that, right? In being able to automatically recognize the events, and then also to learn the behavior scripts that are then used to recognize these complex events, right? So having done that, all the hard work, the regression is just a straightforward linear regression. Yeah, as to whether or not it overfits, we had actually 2 demonstrations. So it was actually quite robust across the 2 demonstrations. So I think we need to do a bit more analysis on that, but I think it looks pretty good at this time.
Yeah, I have one last question online. That's on what is the biggest challenge in assessment of human factors?
Wow, okay. The talk here really addresses the bias in human assessment. I guess that would be a biggest challenge, how to overcome the bias, because unfortunately, a lot of human factors is subjective. I mean, you observe what a human does. So to me, I think that would be the biggest challenge, how to overcome this bias in assessments.
Okay, great. Any questions from the floor? If not, thank you, Kenneth.
Thank you.